Hey y'all, good morning. In a happier mood today. I told you my bad days only last so long. And it actually kind of turned around when I did the Zoom session my second, third period yesterday. That was really great. We had, I think it got up to like 32 kids out of like the 40, which was awesome. It was so good to see people and just hear one another's updates. Fourth period, your Zoom call is today. We'll get to that in a second. Here is your TikTok. Gotta love being offbeat and having no rhythm whatsoever. Really interesting. That had 2,000 views in a matter of 1 hour, and then it completely flopped, so that's interesting. Thought I was going viral, freaked out for a solid minute, skyrocketed, and then it plummeted. So here's some reminders. You should have heard from your homeroom teacher this week, asking you some questions about internet access, Wi-Fi, whether or not you have a tablet or computer available, and all of that. If you have not heard from your homeroom teacher, please send them an email. They've been trying to get in contact with you. Fourth period, your Zoom is today at 11 o'clock. Sixth period, yours is Thursday at 11. I'm going to do things a little bit different. I tried to do it yesterday, but I didn't have the settings correctly. I think Miss Siami and Miss Bellish have been doing it, but we're going to do some breakout rooms today. Really freaking excited about this. I'm going to try to pair you with your friends, and you got some time to like talk, like 4 or 5 minutes or something. And that's going to kind of be one of the opportunities for the rest of the year. So, minor changes are coming your way. We are going to be moving and transitioning into Schoology. I'm trying to say not everything that I know, because I'm still waiting on the implementation side from JT Moore. The good news is that JT Moore has been doing more than pretty much every school in the district at this point. So the changes as you're going to see from us are only on a platform. So everything that we're going to be doing at some point, I believe it's going to start on Monday, is going to be through the application called Schoology. Okay? Right now, what we've been hearing from the district standpoint and the school standpoint, that families are overwhelmed because teachers are sending 7 to 10 emails a week. You have to go through all these different emails, pick up all this different information, and it's really, really challenging to see everything in all these different places. And then you have to go to 5 different links for each school or for each class, and then it's just overwhelmed and people shut down. So Schoology will house everything for your classes on one website, and then the external links may just go from there. So you may have a link to my website, a link to my YouTube video, and things of that nature. But that will be really, really helpful, and it's also going to help us track data. So another change, and Dr. Hughes will explain all of this, is that the online learning, now that we are giving out technology, will be mandatory. So those of you who have been like, oh, I haven't really been doing much, I don't know what mandatory means. I know that we are not taking grades. There will be no grades. But the expectation from the district standpoint is that the learning continues. And a lot of you guys have enough like self-motivation, drive, and initiative in order to keep pushing yourself. But this is just kind of a district standpoint to say, hey, we still have 5 weeks of school, and they're going to be tracking data of how much you log in, how much you interact on like the posts that we post and things of that nature. And then I'll probably post some like quizzes and tests and like discussion boards that again are going to be ungraded, but be opportunities for you guys to really prove the mastery of the material that I've been teaching over the last 5 weeks. And there will be new standards that they want me to teach as well. So way more information to come. Dr. Hughes is going to probably do a call out and email, and we'll have more for you guys soon. So don't freak out. It's really, really minor changes. It's just going to be through a little bit of a different platform. All right, so just as we do every single day, including on the online class, click pause and answer these questions. Here we go, 18x. You combine like terms. The reason why you can combine is because they have the same last name. Distribute the 5, 50x. Distribute the 5 to the 3, and you get 15x. Nope, not just 15, sorry. Distribute the z, and you get 8z. Distribute the 6, 2 to the 6, and you get minus 6z. Then you can combine like terms, they're the same last name, you get 2z. Look at that. 2 statistical questions. You guys have been practicing this. Basically making sure that you have a varied data, and it can't just be like, how many people do you like? It's like, how many people do the students of 6th grade like? All right, order of operations. Wow, this one's really, really annoying. 9 to the power of 3. Remember, it is PEMDAS. 9 to the power of 3 is 9 times 9 times 9, which is 729. So then you rewrite 729 minus 10, bring the parentheses down, rewrite this problem, and then you do 25 minus 4, because you got to also do the parentheses, and also 729 minus 10, so you get 719 plus 7 times the quantity of 25 minus 24, which will give you 1, multiplied by 10. And then we will do the multiplication next, which is just 7, and do 7 times 10, which is 70. 719 plus 70 is 789. Look at that. Alrighty, so we do the exponent first. Well, let's do the parentheses first, because it's parentheses, then exponents. So you get 13 multiplied, ooh, yikes, by 8, minus 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, minus 11, because 10 plus 1 is 11. So 8 times 13, I'm using my calculator, is 104. 104 minus 16 is 88. And 88 minus 11 is 77. Okay? The purpose of this is for you to practice multiplying decimals, and also remembering that the word product means the answer to a multiplication question. So you do 4, 1, 2, 7, put your decimal cloud there of 2, multiplied by 18, and your product should be, I want to save time, is 74,286. 74,286. Put your decimal back, and you get 742 and 86 The sum is an addition question, so you're adding 29 plus 81, and you get 110. And the quotient of 89 and 9, quotient means a division question, and that gives you that. Please, please, please go to Myers and Miss Larson next year, and then the new guy, Mr. I forget his name, and make sure you understand these words. These words are so important. Uh-oh. Hopefully I don't have the corona. All right. Goals for today. You can recognize when a histogram is appropriate for a graphical display of data, and you can use a histogram to get information about a distribution of data in real-world situations. It's going to be a lot of me talking, just like the rest of these videos. This should be a discussion-based lesson. However, that's impossible. Okay. So this is a picture of a histogram. It looks like a bar graph. However, all of the bars are completely connected. So if you look at the bottom of the page, it says that this is describing the weight of pounds for dogs, okay? And it says in the histogram that each bar includes the left end value, but not the right end value. So for example, this first bar right here includes dogs that weigh 60 to 68 pounds, but not the 80 pounds. So if you see the 80 pounds right here, you're like, well, isn't that first bar saying 80 pounds right here? The answer is no. This is the 80 pounds, so the left value includes the first part of the data, and then the right value does not include it. So the 80 pounds includes, because it's the left bar, this next bar right here is right here. So there is 10, I believe that's 10, maybe it's 11 dogs that weigh 80 pounds. Okay, so we're going to go really, really deep into that and how to analyze histograms and things of that nature for today. So thank you for joining me. Miss you guys a lot. All right, so here is the histogram, same histogram that you've seen. Excuse me. And it's asking us to answer some questions. So the first question right here says, how many dogs weigh at least 100 pounds? Keyword here is at least. Let's zoom in on the graph. And if you look at B100, you know it goes to right here. But it's at least 100 pounds, which means you need to weigh 100 or what? More. So you have the 14, plus you have right here, which is, I'm guessing, hopefully 5, which is 19. This graph isn't very good. That's 3, which is 22, and then this is 1 right here, which is 23. So yes, that is correct according to the answer key. So 23 dogs weigh at least 23 pounds. So again, you're looking at the left side of the bar and going across to the y-axis. How many dogs weigh exactly 70 pounds? Exactly 70 pounds. Well, see, the problem is we don't know, because if you look at this bar, it goes from 60 pounds to, they said 68 in the prompt before, because this bar right here cannot be said that this is 70. So it is complete. So the answer to this is unknown. It can be anywhere between 0 and 6. Histograms show a distribution of data. So how many dogs weigh at least 120 pounds, so, and less than 160. So that at least means right here, I'm going to put it in red this time. So we look at the left side of the bar, so it needs to be at least 120 pounds up until the 160. So it needs to be less than the 160. So the answer for that is we have 5 dogs right there, and then we have 3 dogs right there, and we can't go up to the 160 because it has to be less than. So X has to be less than 160. Not less than or equal to, but less than. So it is 8 dogs weigh at least 120 pounds and less than 160. So the next question says, how much does the heaviest dog at the show weigh? The heaviest dog at the exact does it weigh? We don't exactly know, but we do know the range from this data point right here that I'm putting in green, that it has to be between what 2 values? 160 and 180 pounds. So how much does the heaviest dog weigh? The exact weight can't be determined. No exact. But we know that the range is going to be at least from 160 to less than 180. So I'm going to say less than 180. Can't include 180, but it can be less than. Okay, our next prompt here says, every 10 years, the United States conducts a census. A census is a national survey. We actually just did it. So if you haven't filled out your census for your parents, make sure they do that. That's how a district gets money, for the school district gets money. Anyway, which is an effort to count the entire population. The dot plot shows the population data from 2010 census for each of the 50 states and the District of Columbia, which is, D.C., Washington, D.C. But look at this dot plot. Can we learn anything from it besides we know there's one state that has right around 37 million? Like, what about this mess right here? We have no idea how many states there are because there's so many dots that have different values that we can't really determine it. So that is why histogram is going to be really, really a better case for us to use in order to understand the distribution of data. So what we're going to do is we're going to look at this dot plot and see, can we answer these statistical questions from just the dot plot? Okay. So the first one so it's supposed to ask, is it easy or impossible for us to answer? How many states have a population greater than 15 million? Well, we know that 15 million is right here. Let me zoom in for you. So yeah, we can easily see that because there's 1, 2, 3, 4 dots. So that's easy. Which states have populations greater than 15 million? Is that the same question? Oh, which states have populations greater than 15 million? Do we know which states from this graph? No, so that's going to be an impossible statement. Then it says, how many states have populations less than 5 million? Let's zoom back in. Can you see clearly the dots that are less than 5 million? No, they're all jumbled together because there's a ton of them. So that would be impossible to determine from this graph. What is a typical state population? That would be really, really hard for us to determine because there's so many dots are indistinguishable and like unable to comprehend. It's hard to determine a typical state population. And then the next one says, are there more states with fewer than 5 million or more states with people between 5 and 10 million? So then between the 5 and 10 million is this group like probably right here. But again, that'd be really hard. You could probably guesstimate and say it's that group right there, the first group, the 0 to 5. But it's really, really impossible to tell because you really don't know how many states are in that range right there. So that would be really, really hard to tell as well. And the last question is, how would you describe the distribution of state populations? And that's going to be hard because the dots overlap a lot, and it's difficult to give a good measurement of center and spread for this data. So let's look at all of the populations from the United States. This is in millions, of course. So let's go ahead and find my good old state, Georgia, my home state. It says there's 9,690,000 people in the state of Georgia as of 2010. So that number has skyrocketed since then as Atlanta has exploded. Probably the same thing with Tennessee and Nashville. It says Tennessee has 6 350,000. 6,350,000 people. And so it'd be really, really hard to tell on that graph from before, the dot plot, to see the difference between those two states when Georgia has almost 3,300,000 people more. So what it wanted us to do is it wanted you to create a big old frequency table, compiling all of this data into an easy to read chart, and that would have taken me like 25 minutes on a YouTube video. So I just went ahead and made it myself and typed it up and put it into this frequency table for you guys. So if you look, there's what this means, if you remember from the conversations we had earlier in the week, there's states populations in the millions. Of 0 to 5 million, there's 29 states. With states from 5 to 10 million, there's 15 states. 10 to 15, 3, and so on. That is why in this section right here, it was so hard for us to see how many states there were, because there was literally 15 plus 29, which would be 39, 44? Yes, 44 states in one little small section of data. So the dot plot is not always the best representation of our data. Okay, so let's look the histogram for this. So now you can see that there was 29 states here from 0 to 5. We don't know exactly what the millions are. We could do individual graphs, but that'd be really hard to see 50 bars. But it does show you the range of and the curve of the data, where you know that the majority of the United States have a population from 0 to about 10 million. And then there's some others right here and there. So now let's look at the same statistical questions and see, can we answer them now based off of the graph? So, how many states have a population greater than 15 million? Yep, still pretty easy to tell. We can tell from right there. So that's easy. Which states have a population greater than 15 million? That is still impossible because we don't have states' names unless we looked at the table or the chart. The third one, how many states have a population less than 5 million? So you know that now this is easy because we know that it is 29 based off this one graph. So now that is easy, but before it was impossible. What is a state population? The typical state population, and from the histogram we can estimate that a typical state population has fewer than 10 million people, because you see that 44 states up here have less than 10. So now that's pretty easy, where it used to be impossible. And then are there more states with fewer than 5 million people or more states with between 5 and 10 million people? That is now easy as well because we can compare it using this section of the data right here. So now we can interpret that. And how would you describe the distribution of state populations? That is now easier as well because it's more precise that the histograms showing the population sizes are in intervals of 5 million people, where before with the dot plot, they're all just kind of bunched up with the same interval of 5 million people, but you couldn't see it with all the individual dots. So this shows you that sometimes histograms are going to be better uses of data, just like box plots will be better use of like statistical data of like test scores and things of that nature. And the dot plot would be better for seeing more like an individual, more spread out data. So yeah, that is a brief introduction for today. I'm trying to start working and converting everything over to Schoology, so the lessons are kind of light this week as I transition and figure out what new standards they want me to teach. Hope you all have a good day today. Fourth period, I will see you at 11 o'clock today. It's going to look really, really different. I'm really excited. I have some challenges that we're going to do. It's going to be fun. I really hope you guys tune in. It's going to be good to see you guys.